Hello everyone, this is Ivan, and today we continue study MATLAB, and I would like to propose you to try to estimate graphs, and in most time we will be focused on detecting on the shortest path between waypoints. As you know, graph it is quite a useful representation of data. Usually we use nodes and edges. Nodes are connected between each other with the help of edges. That's why edges it's like a line which connect two different nodes. In many different tasks we can apply graph, beginning from economical tasks and ending traffic networks. And in many cases, graphs and graph theory helps to solve many different tasks and help to describe this task, help to get a solution with quite clear and easy understanding what's going on. That's why today we will try to play a little bit with small graph and try to find uh, the shortest path between two waypoints in this graph. This task is typical for any navigation equipment which we have in our usual life. Because localization of uh, yours location, it is one task of navigation, and the second task it is guidance or direction of your movement to the pre-planned trajectory. Because in navigation we consider movement from one point to another one. That's why detection the shortest path between waypoints. It is the second quite important task of navigation, and it can be referred for any types of navigation. For cars or road navigation, in this case we can consider roads network for finding the shortest path between two waypoints, like your location and destination point, which are very popular in modern mobile applications when we can just click and get in the shortest path. And in this case, we can use different criteria. Next one, we can find the shortest path for ship traveling or for vessel guidance, because sea navigation or navy navigation is also quite important component of transport system. However, in this case we operate only in two dimensions. If we talk about aviation, it's one of the most complicated tasks. Aviation and maybe space navigation includes positioning and getting the effective trajectory between two waypoints. And aviation and space navigation, it's more complicated because in this case we need to consider two planes, horizontal and vertical one. And in this case, tasks of navigation in three-dimensional space may be a little bit more complicated than in two-dimensional. If you talk about effective path search, in this case, usually we can use two different criteria. The first one, effective path, may be calculated by the smallest distance between waypoints, which can be supported by network of roads which we consider, or it can be based on time of traveling. And in this case, we take into account like traffic data, because at some ages probably we can get some difficulties in traffic flow, and that's why we need to take into account how many time we spend for traveling from one age to another one. If we talk about aviation, in this case, of course, three-dimensional trajectory and the minimum length are the most important, because usually aircraft cannot stop, and traffic does not provide very uh, very big influence into their time of traveling of airplane from one point to another one. That's why length of airplane trajectory, it is the main criterion for getting optimal or effective flight plan. And actually today I would like to play a little bit with MATLAB, and we try to use a network of airports as a simple example of any network. That's why you can use it for any uh, kind of networks. And then we will try to represent this network as a graph. That's why I will build uh, a graph of this network. Then we will count weighted graph. Next, we will estimate weighted degree of this graph, and then try to represent it in MATLAB in form of specific plot. And then we will try to find the shortest path between any pair of runways in our network. And then we also visualize this shortest paths into our total graph, and try to count how often each waypoint of our imagine network participate in the shortest path of each pair of our waypoints. In this case, this assessment give us give us possibility to understand which node potentially can hold the most traffic. That's why in this case we can classify nodes by imagine workload of network if we simulate air traffic with their equal airflow performance for each pair of runways within specific airspace. That's why let's start to do that. Of course, we will need MATLAB. That's why I will switch to MATLAB. Also, here you will see that I've got already some script which is actually clear, and next I just fill up the script to code what we will need. Also give me a second. Okay, and we can start. As usual, uh, when we work in MATLAB, we need to start from preparing MATLAB environment for our computation. First of all, we use CLC as usual, then clear vars, then close all, because I like many different figures. Then we need to specify identification codes of our waypoints and location. I will use graph which is connected to runways within Ukrainian airspace. And of course, each waypoint or runway has particular identification code and location in latitude and longitude coordinates. That's why I don't want to show you how I code it. That's why I just code three matrices with ICAO identification codes with latitude and longitude of this waypoint's location. Then we can start to create our graph. However, before it, I would like to count weight of each edge. Also quite important when we talk about graph, quite important description of graph, it is order of graph, which is equal to number of nodes. That's why order of graph is equal to number of nodes. And size of graph, usually it is number of edges. This is also quite important. And up to now, let's start. And I would like to transform everything from latitude and longitude to some metrical system within Cartesian reference frame. And as you know, we use ECEF reference frame. That's why I will create matrix ECEF, and I will apply function LLR to ECEF, which convert coordinates from latitude, longitude, altitude to X, Y, Z from the center of our planet. And we need to specify matrix of latitude, matrix of longitude, and matrix of altitude. Of course, if you would like, we can use like real altitude above mean sea level, which we can find in different databases for runways or for any waypoints. However, in our example, I just put it at the ellipsoidal surface. If you remember, in GPS we use VGS84, reference ellipsoid. That's why I just put altitude is equal to 0. And it means that all airports are pinned on the ellipsoidal surface. That's why I use zeros function to create a matrix of 0, which will be like the same size with latitude and longitude. Therefore, I will use numeral function to get number of elements in latitude, then comma 1, because I need only one column. And then we've got distances. Okay, we've got coordinates. Next, let's try to count combination of each waypoint. We've got many of them, even I don't know how many we've got it. However, I would like to find all combinations of these waypoints by 2. In MATLAB also we've got quite good function, which is combinations. I think it types like that, and we will specify that we will use numbers from 1 to null of IKO matrix, and it should be combination by 2. And then we can easily find distance between counted combinations, because S, matrix S. Okay, let's run it, and you will see that, okay, combinations. So you see that MATLAB always help us. And we've got that matrix IKO holds 16 cells. It means that we use 16 airports in our network, and it will be equal to our nodes. And also then you will see that we've got matrix S, and if I click it twice, you will see that we've got 120 different combinations of our 16 waypoints. And here we've got two columns. One column will be referred to 1, to the first waypoint identification number, and the second one for the second one. And next, I would like to find the distance between the first waypoint and, for example, the third one. That's why we will need to find length of each edge between waypoints, number of each are specified in first column and in second column of matrix S. To do that, we will do like as usual. We just type d, which means distance is equal sqrt, because I hope you remember formula for find distance between two waypoints. And then it will be equal power by 2 difference by coordinates. And in this case, ECF, we need to use matrix, and then we need to specify that it will be matrix S, and we need to use all the lines. Yeah. First column and first column of matrix ECF, because it is X coordinate. Okay, I've got it. Then we use minus. The same, however, here we need to specify second column of matrix S. It means first column of matrix S and waypoint of second column. Then we need to repeat it for y coordinate. And y coordinate, it is the second one. That's why we just need to change to the second one. And the same for the third coordinate. That's why I just put in 3 here. That's all. We've got our distances between waypoints in meters, because LLR to ECF give output in meters from the center of our planet. And then we can easily plot the simplest graph. Let's do it. That's why graph G will be equal graph, yep, and we need to specify identification. It will be S first column and S second column. Yep, and then we will use weighted graph. That's why we specify D, which means distance between waypoints. That's why D, it's like a weighted coefficient. And then we specify IKO code of this graph, because finally much more better to get label of waypoints. And If we run it, let's run it and check if you've got everything is okay. That's why G is a graph which includes ages and nodes. And if you click on ages, you'll see, okay, we've got ages, and we've got ages identification by title of this waypoint and weight of each age. And that's why now we can tell that our graph, which I consider has 16 order and 120 size. Okay, let's continue. Then usually we will plot agency matrix. Okay, if you would like, we can do it. Agency matrix of graph G. Okay, adjacency matrix. Yep. And if you can click on agency matrix, you will see which elements we have. And agency matrix in MATLAB is like one quite long row matrix, which includes only true coordinates of logical true location. Yep. Let's continue. Next, we've got everything, and we can plot the simple graph. Usually I would like to begin a new section of code because it will be plotting and I don't want to resimulate the whole code. That's why I broken script in MATLAB into plotting part. And then let's start from figure because figure is like it's a good window for representation of our results. And then I like to specify color as white, white. Then I like to specify name of this figure and let it be weighted graph. Yep, and then we can plot. Therefore, we just use plot, then specify title of graph G. Then we will use settings for X data and Y data. That's why X data will be referred to longitude. Okay, sorry. That's why I will apply longitude matrix. Then I will use Y data and I will apply latitude. Then also let's specify marker, marker sign, and I like zero circle. That's why I will use just O. And also let's specify marker size. Marker size and let it be 13. Okay, and next it is good if you specify Y label and X label. So for Y label will be latitude, latitude in degrees, Then Y label or X label, will be longitude, in degree as well. And finally, let's specify title, which will be equal to the name of our figure, just weighted graph. And that's all. Let's run this section. Therefore, we just can click right button on our mouse, and we can go to evaluate current session. And in this case, we got our graph. This graph includes connections with each pair of nodes. And for further simulation, we maybe a little bit modify it. However, also I would like to plot a weighted node degree of this graph to make clear understanding which node includes multiple connections and has the most distances from all other nodes in our graph. And to do that, I also create a new section. Then I just copy figure, and in this case it will be weighted node degree. Just a second. Node degree. Yep. And also we will do the same plotting. However, result of our plot we will put to matrix P, to variable P, and then we will count centrality of this weighted graph. Therefore, we apply function centrality, yep, from graph G to count degree, and also we specify importance of each age. And to do it, we need to specify a correct path to getting weights. Okay, as easier way we can use just matrix D. However, if we forget about, we always can use path in our structured or graph data. That's why G is our graph. Then we are going to ages, and then we use column weight. Yep, we've got our centrality. Then we specify in graph P, in our plot of graph G, which means P, we specify property of node C data, which will be equal to our weight. Yep, then it will be also better if you specify color scheme. That's why we use color map, and let it be jet scheme. Then let's also specify color bar. However, I would like to locate it in specific location at the below our graph. That's why I put H is equal color bar, and then I specify that Y label will be from H will be weighted node degree in meters. Weighted node degree in meters. Yep, and then we just can copy our Y label, X label, and title. That's why I will put it here. Okay. Okay. Just a second. Y label will be latitude, X label longitude, title weighted node degree. And if I run it again, evaluate current section, we've got something like that. And here you will see that color scheme of this node indicate for us the most distance or the most widespread waypoints in our graph. And this matrix shows for us in meters the total sum of ages from each node. And actually we will see that UKLU is the most longest waypoint, maybe not far away waypoint from our network. And let's go next. Next, let's try to find the shortest path between any two waypoints. We can use any of them. Let's use between UKBB and UKLN. Let's try to use this network to find the shortest path. However, we will try to ignore the direct path because during the combination finding we've got any connections between any pair of waypoints. That's why I just would like to remove a direct connection, then create new graph, let it be like G1, and then try to find the shortest path between all of these waypoints. Also quite important that shortest path, it is the one path. We can use different algorithms to find the shortest path. However, each of present algorithms give us the same results. The difference between algorithms is only in time of calculation. That's why algorithm we can refer to better algorithm if it gives us the lowest time of finding or searching this the shortest path. That's why quite important. Any shortest path algorithms in IT theory should give us unique output, unique shortest path. And the difference only in time of computation. That's why it doesn't matter which method we will use because our graph is so small, small number of order and small size, and it means that we can apply any method. And of course, in MATLAB, we've got integrated function, which called like shortest path, which give us the speediest way for finding the shortest path. That's why I don't want to touch a topic of different methods for searching the shortest path, because actually in framework of our navigation purpose, we just can use one of the 30 different algorithms which give the best results. Of course, if you talk about like road traffic and transport task within the map or road traffic, and in this case we've got graphs of high order and very variable size. And in this case, algorithms of searching paths, we need to select quite carefully because some algorithms can miss the shortest path. That's why we need to adopt for particular graph configuration of our algorithm. However, in my case, I just would like to specify number of pair which I would like to show the shortest path. Let it be like pair is equal to, Then I will create new matrix SR, which will be equal to our matrix S, which includes combination, and just try to remove uh, the second the second or path which I would like to search. That's why I need just to remove the data about this H connection. And also, because we use weighted graph, we need to do the same for weight coefficient or for our distances. That's why I will apply clear, then any columns is equal nothing. And then we can create the same graph, however I will call it G1. Thus G1 will be equal graph. Here it will be SR, SR, and SD. Yep. And number of nodes we still the same as we've got. And then let's try to plot it with the shortest path. That's why next I will need also to plot a graph. Maybe I will copy the first graph just to don't repeat it. Then I will specify the title, the shortest path between waypoints. In order to check which waypoints it should be, I can go to matrix S, and we will see that it will be the second one. Therefore, the first waypoint in my case, it will be UKBB, and the third one UKLM. That's why I can specify the shortest path between UKBB and UK, how it's called, LM. UKLM. Yep. Then I plot the same graph. However, I will specify G1. Longitude, latitude, still the same. Yep. Then I can apply title. Also, I will copy this name to the title. Y label, X label, still the same. And then we can go to the shortest path. If you go to description, you can, or MATLAB help, you can find that shortest path function give us shortest path. Thus, I will use also function shortest path. Like what you would like to get, you just need to type in English language. And then I will specify that I will use graph G1, and I need to specify identification code of waypoints, which specify start point and final point or destination waypoint. And in this case, we need to use ICAO identifiers of these waypoints. That's why I can just select UKBB, comma, UKLN. Yep, and then there are specific settings for method. However, I would like to try without this like specification. And then if I run it again, Control Enter, we've got the same plot. However, let's look what we've got in output of our function, the shortest path. That's why it should be parse 1 I've got, and if I click it, I will see that the shortest path between UKBB and UKLM will be through the waypoint UKWW. Yes, and it is true because all of them are located approximately at the same line. That's why UKVB, UKWW, and then UKLN. That's why the shortest path gives us solution. And matrix R includes distance in meters from one point to another. That's why this distance of shortest path in meters in our case. Then let's mark this distance in our graph representation. And to do that, in MATLAB, we've got function highlight. Thus, we use highlight, highlight. Then we need to specify figure, and to do that, we need to go to plot, and then specify title for our plot. Let it be p1 is equal like our plot, and then here we can specify that p1, and then also we can put identification of our waypoints, ICAO, and okay. Then we can also specify like different properties. I would like to just introduce not color for you, and let it be green because in previous it was blue. Marker size, okay, marker sign, let it be square because previously we used circles, and marker size let it be a little bit smaller, 9. Okay, and okay, and then let highlight uh, the path light, also P1 we use, and then we specify our path 1. Yep. And also there are properties H color, and it is logical to specify it by some maybe colorful color like red or magenta. And if we run it, evaluate current section. Okay, sorry, I've got mistake somewhere. Let me check. Highlight. Okay, I forget highlight. Okay, run one more time again. Okay, and I've got results. That's why in this case highlight ICAO, it means that we put titles of waypoints at each node. And the next highlight specify our path as a red color. Therefore, quite easier. We just need to specify graph, then we need to specify like a set of waypoints that we would like to highlight, and specify a color or marker size or marker color, not color, and we've got it. Okay, however, I would like to continue, and we will go to the core of our task, because I would like to find the shortest path for each waypoint, for each pair of waypoints, and then count how many times each waypoint participate in this shortest path. It means that in ideal, if you've got airline or maybe some traffic company, And usually, in order to minimize price, they select their shortest path for trajectory. And it means that each user will travel within the network by shortest path. And if you count how many each waypoint participate in the shortest path, it means that we can count some kind of centrality which indicate the weight or participation of each waypoint in traffic. If you apply uh, like random simulated traffic for each passes, for each shortest passes. And in this case, if we identify these waypoints, it means that we need to look carefully for these waypoints and compare it with the real traffic data and check if it will be correlated. And it should be correlated because the most frequently used waypoints in this case will be correlated with the results which we obtain for the number of participation in the shortest path. However, to solve this task, I do not want to code too much because we've got everything in our previous task. That's why I just copy many lines from our previous task. That's why, first of all, we need to plot graph. That's why I just change a little bit of name and title. That's why it will be participation in the shortest path. Okay, I think we can left not participation in the shortest path. Okay, not participation. Okay, not participation in the shortest path. Then we will plot a graph G and let it be P2 because P1 we already have. Therefore, G, it will be our total graph. Okay, all other parameters we just left as we got. Then I will use a loop for I will change from 1 to number of combination minus 1. That's why I will use size size s size s comma 1 minus 1. No, we need to check any combination, I think. Yep, any combination. If we type 4, it means that we need to add and. Then I will do the same. That's why I will copy these first 5 lines. Then I will put it here. That's why let it be SR. However, in pair, I will use I identification because I it will be number of pair. And then we will create graph 2 because graph 1 is already present. SR, SR, SD, and ICAR. Everything we left as we have. Then I would like to copy the shortest path. Yep, let it be path 2 and R we will accumulate in matrix R capital letter. And the shortest path of graph G2. And then we need to specify in quote our title. In this case, it will be ICAO. Then we will specify, let it be as I from 1, and the second one, let it be, okay, I just copy maybe it to avoid some typos. It let be 2. Okay, and then also we will need to highlight this ages. That's why it will be P2. Okay, P2, because we've got plot and we would like to just highlight some paths on P2. And these paths, it will be path 2. And also use, okay, let's use magenta. And also, I would like to count or to accumulate titles of waypoints located in on the each shortest path. I will apply like triple P variable, and it will be matrix which will accumulate paths. Path 2. Yep. And also I will need to specify triple P at the beginning and let it be equal 1, and at the end, okay, I will just delete the first element. That's why we need first element, because it is in the loop. Without initial data, this line will generate error. That's why we just need to delete initial uh, cell of triple P matrix. And also, due to usage of multiple variables here, we need to clear all of them. That's why we can use clear SR, SD, G2, pass2, yep, pass2, pass2, and that's all. Okay. And finally, I just would like to add title also at the end, which will be equal to not participation, not participation, the shortest path. Okay, oh, we've got it. Up. And probably we can run our section. Also, I like to do something like that. Here is a smart ident. Okay, and our code looks much more better. Thus, we can run it, evaluate current section, and let's see what we have. Yep, everything is great. And now you will see that we've got our graph. We've got a lot of paths marked or highlighted by magenta color, which means the shortest path passes between waypoints. However, direct path or direct edge between waypoints is like missed. That's why usually direct connection with like more far away located waypoints still unuseful, and the most central paths used quite often. Next, let's count how many waypoints participate, how many times each waypoint participate in the shortest path between pairs of waypoints. Okay, that's why we've got triple P, and matrix triple P accumulate, just a second, just identification of our waypoints. Okay, you will see that we've got many of them. And now I just would like to count how many times each waypoint are present here. And it will be our weight, which we indicate in our graph. Therefore, to count how many times each of this airport identification participate, I also need to use loop to count participation from 1 to numeral of elements in matrix I have. Yep, and okay, home. Okay, and then let it be some matrix V from Y will be weight or number of participation, and I would like to string compare, and I will use array string array triple P, and I have identification. That's why after the comparing, it will give us the matrix of numbers where we got successful comparison. Then we will use find to count like logical how many elements we've got. And yep, at the end we need to just count how many results in find we've got. Okay, it should be something like that. Thus, let me resimulate it. We. Okay, that's why we've got 16 waypoints and we've got some numbers. And these numbers talk us about how many times each waypoint participate into the shortest path. And then let's add this data to our already prepared graph. And let it be P2. That's why P2 node data, node C data, let it be equal to P. Wait. Then color map will be red. And also let's specify H2 is equal color ball. And let also, I will show you how it be possible to change location of color bar. That's why we just need to type H2 and then specify location. And then we can specify location south outside. Yeah. And Y label. However, I would like just to copy Y label. Just a second. Oh, Y label. And okay, probably we can just copy all of that. Okay, and Y label, it will be number of node participation. Number of node participation. We don't need meters. And latitude and longitude. And let it resimulate. Okay, and we've got results. Okay, probably just a second. I've got mistake. Okay, south outside. We need like that. South. Okay, I missed T outside. And probably I will resimulate everything. each of our graph, and then just move it for the total screen. Okay, that's why, just a second, I will make it a little bit more suitable for you. Okay, that's why today we have tried to, okay, label for our, why not, just a second, why label, okay, H2. So, let me resimulate everything one more time. Okay, and let's move everything in one screen. Okay, that's why today we have tried to play a little bit with uh, shortest path detection in graphs, and you will see that it is quite easy. That's why we spent approximately 30 minutes to plot 4 different visualizations of this graph, and we analyze the shortest path, and we analyze participation of nodes in different shortest paths. Of course, in MATLAB, you can find betweenest centrality, because in function centrality we can select like betweenest property, and in this case we can count the same. However, usually in like big traffic network, we've got specific circle of waypoints, and in this case we need to specify a set of waypoints for which we would like to use the shortest path. That's why in this case handmade approach for finding the betweenest centrality for specific group of waypoints can be useful, which we use actually today. That's why today we plot a graph of airports within Ukrainian airspace. Then we count weighted node degrees for each waypoint with the help of graph visualization. You will see by color, and here we've got it in meters. Then we try to find the shortest path between any group of waypoints. Uh, However, okay, first of them we use just 2 of them, and it was from UKBB to UKLN waypoint. And then we count the shortest paths in the loop for each pair of waypoints. And in parallel, we count how many times each waypoint participate in the shortest path. And it is some kind of uh, counting the busiest waypoint if we apply the same traffic by each shortest path. And also, we quite easy solve this task and visualize with the help of MATLAB. And that's all approximately for today. That's why thank you very much for being with me. Uh, I was glad to help you. That's why thank you very much. Hope to see you again on the solving of some practical tasks in air navigation. Good luck!